Hey class, Vega here. I'm just doing a Sudoku 9x9 grid, and I'm having problems solving it. I just can't seem to make the numbers fit. I sure do wish that there was a shortcut to solving this. But what if there was? Now you may be asking yourself, well Vega, what do you mean you're having trouble with it? I do these all the time, they're pretty easy. I could do them really fast. What's so hard about them? Now that's partly because of the speed at which we do the problem. Solving a Sudoku takes steps to complete, an algorithm if you would. Now this algorithm is same for both of us. I check to see if the numbers that I put in the grid would be allowed to be put in there, and I see how it affects of the puzzle as a whole. And I also see if there are any potential consequences for any number that I put. Now, you on the other hand may do this more or less the same way, but just as fast a rate. The code is the same for both of us, just different CPUs if you would. But is there a shortcut to bypassing all of this? Is there a way to make all these steps unneeded and make the Sudoku super easy for both of us? That's what P versus NP is all about. P is polynomial times problems. That means problems that are easy to do and easy to check. NP is non-deterministic polynomial problems. Those are really hard but easy to check. What I mean by this is think of factors. Yes, I know we all love math. If I were to give you the factors of a double-digit number and made you give me the factors of it, it could be easily done, and you giving me the answers, I could easily check them. But if I were to give you a 1,000-digit number, then the problem becomes exponentially hard. Now let's say I give you the factors to the problem. Well, then suddenly it becomes just as easy as P. All you had to do, what we could take from this graph, well, we can clearly see that there's an anomaly of NP complete. But more on that later. Well, what about where all the data is? This data graph does not have a source per se. It's more of a mathematical representation of every source there is. Being that, showing how every P problem is linear and every NP problem is exponential. Now why is it every source? Well, because math is everything in the universe, and every problem we face in its core form, from astrophysics to biology, is math. The ends of each axis have, in theory, no end, meaning the number of problems for both P and NP is unending. There are problems in the graph that we have even yet to discover. But when looking at the scale of both of them, it brings a question. Are they fundamentally different problems because of the difference in numbers for P and NP? Well, back to factoring. At what point does the digit number that needs to be factored for stops? Can I make the number? Well, I can make the number as big as I want. There's nothing stopping me. Now, that's a problem because computational processing has limits in space and time. That's absolute. There's limits to how big a problem can get. How much memory will it take up and how much time it will take to actually solve the problem in a reasonable amount of time. But what if we could bypass this, like the Sudoku, where we could have a shortcut to the answer without having to be told the answer to it? How do we make P equal NP? NP complete is that theoretical shortcut to all exponential NP problems. Because all problems in the core are just math, and NP complete hopes to exploit that concept that everything is connected through math. If we were to find the shortcut to an NP problem by way of NP complete, we would find the shortcut to a really large numerical problems. But here's the thing. No one knows if there's even a way to find NP complete. If P does not equal NP, then we would know that there are really hard problems that not even computers can do, or for that matter, anything can do. Imagine if I kept expanding the grid to the Sudoku puzzle. Each time I'd be exponentially expanding the size of the problem and time it would take to solve it. All the factoring and variables and checking that would go into solving it would be too much. P versus NP is a millennium problem, and it has to do with the very nature of computer science and how we understand algorithms. Sudoku is an NP problem in and of itself through P by 9x9 standards. but truly exponential NP when we go beyond the notion that it's only a 9 by 9. Those people that would ever find or know the shortcut to a Sudoku puzzle, that by passing all other steps to the algorithm, then you would find NP complete. You should tell someone important in the field of computing because it would revolutionize computer understanding.